Good evening, everyone. So today I am talking about binomial distribution and how to solve certain problems on Excel by using binomial distribution. So first of all, I wish to discuss the formula which is given by James Jacob Bernoulli. This is the formula of binomial distribution, in which we can always talk about probability of capital X is equal to X is NCX, PX, Qn minus X, where capital X is representing the random variable, any random variable which I am interested in calculating the probability of. Small x is probability of success. That means this random variable it can be defined in the nature of success and failure. So this capital X can be defined in terms of small x, that is successes, and not successes or the failures. You can call it y or something else. And so I am interested in calculating small x successes of the total values which random variable x can take. That can be given by NCX, where C is representing combinations, small n is number of trials, small x is successes again, and P, small p, which is representing the probability of success, which I have already mentioned here also, probability of success, and Q is probability of failure, which can be given by 1 minus Q. So it is pretty clear that every binomial experiment need to be defined in the terms of success and failure, P and Q. And raised to the power n minus x, that means number of trials minus successes. So this is the fundamental formula, and here I have a question in which I am talking about calculating the probabilities of number of heads in the toss of a fair coin. And we can think about this example like this, that a fair coin is tossed 10 times, and we all know that in a fair coin the probability of success, probability of getting, which I'm talking like success I'm defining is getting a head in each trial. So we all know that probability of getting a head in each trial of a fair coin is 50% or 0.5. So that I already know, and the number of trials are 10. This coin is tossed 10 times. So what is the probability of getting 0 heads, 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6 heads? So these are the all possible values which my random variable x can take. So these are all possible values. So it has to be defined by capital X. So number of heads is given by capital X. Now small x, which you guys must be thinking that how I have defined small x in the classical formula here. This is small x I'm talking about. So small x are these numbers. So this could be x1, that is 0. Then the number here could be x2, and that is 1 head, 2 heads, 3 heads, and so on. So capital X can take 10 success values, which are x1, x2, x3, x4, x5, x6, x7, x8, x9, and x10. And it can also take 10 failure values, which are again 0 to 10. That means there could be 0 tails, 1 tails, 2 tails, and so on. So that's about success and failure. So let's say about probability of getting 0 heads in 10 trials. That means if a coin is tossed 10 times, then what is the probability of getting 0 heads? So that thing can be defined easily by binomial distribution. So I'm going to calculate probability in two cases. One is probability with exact match and probability with cumulative match. So let's start with the function. I straight away type my Excel function binomial test. I scroll down to the function, press my tab key. It gets highlighted. It first asks for number of successes. So I'm interested in 0 successes in this case. Second, it asks for trials. So my trials are 10 in this particular case here. And since throughout I'm going to use these 10 trials, so I'm going to freeze this particular cell by pressing F4 key. Then it asks for probability of success in each trial, which is 0.5 in this cell, which is going to remain throughout my problem. So I'm going to fix it again or freeze it by using F4 key. Then it asks for cumulative or probability mass function. That means the exact match. So right now I'm using probability mass function false. The Excel code for false is 0. So you can use any of these things. Either you can double click on false or you can use 0. Which means it is going to calculate the probability of exactly 0 heads, in the toss of 10 10 trials of 10 trials or 10 tosses of a fair coin, which gives me a value 0.0010. I can drag it down and I get all my cells filled up. I can also plot a graph of this particular distribution, which shows me expected result. So I plot a line graph. So I'll just make it, little that should actually fit the format. So I'll just give it this. Okay, that's fine. That looks now insane. So I can see this particular plot here. I hope everyone can understand it. The probability of getting 0 hits in 10 tosses, it's highly improbable. You at least will get some hits. So, and it keeps on increasing till it reaches its classical value of having 50% times head, and then it tapers down. And the probability of getting all heads on a fair coin again is a very improbable event to happen. That means very less probability. So it's kind of normally distributed data, which the chart you can actually see and think of it. Now I'm going to talk about the cumulative or combined binomial probability distribution. So what is combined probability distribution? Rest of the things will remain same. Instead of choosing false, I'll choose true or cumulative. So numbers, I'm interested in 0. And I'm interested in trials. So there are 10 trials. Again, I'm going to use it throughout. So I press F4 key to freeze it. Then it asks for probability of success in each trial, which is 0.5. I again freeze it by using my F4 key. This time I'm talking about true or cumulative. The Excel code for true is 1. So either you can type 1 or you just press the tab key and the true pops in. And you hit return. The probability, and I drag it down. Now I'll just bring the points down. Right, fair enough. Now I'll talk about what does cumulative mean. So rather than speaking much, I'll explain with a manual function, and you'll understand what does cumulative means. So is equal to sum, and I'll take exact match and freeze this particular cell, F4, enter, and I'm going to pull it down. So if you look into the values which I just calculated manually, cumulatively, they are exactly equal to the combined match. So I just click in this cell and let's see what it is doing. Oops, I hope now you understand what is the combined function. That means cumulative function is getting me probability of getting at most 5 heads. That means 0 heads plus 1 heads plus 2 heads, 3 heads, 4 heads, 5 heads. Similarly, if I go to this cell, this particular function right here, which is same as this, is giving me the value of probability of 0 heads plus probability of 1 head. This is giving me value probability of 0 heads plus 1 head plus 2 heads. And similarly, now I can work it out like this particular function, which is equal to this. If I click on this, highlight the formula, shows me it is actually giving me sum from p is equal to 0 to 8. Probability of 0 heads plus 1 head plus 2 head plus 3 head plus 4 heads plus 5 heads. So what kind of questions I can answer out of this particular whole distribution? So if somebody asks what is the probability of getting 6 heads in the toss of in 10 trials or 10 tosses of a fair coin, so probability of getting 6 heads is given by 0.2051. That means 20.51%. I can convert all this into percentage just by clicking here. Increase decimal 2 points, and I can convert it into percentage if you want to. If you want your answers in percentage, you can easily click it this way. But let's talk about in terms of probability once again. So what is the probability of getting exactly 6 heads? 0.2051. Now what is the probability of getting at most 5 heads? That means maximum 5 heads. So at most 5 heads is 0 heads plus 1 head plus 2 head plus 3 head plus 4 heads plus 5 heads. That means probability of getting less than equal to 5 heads. So that is going to be 62.30%, 0.6230. Now the other question is, what is the probability of getting at least 6 heads? That means minimum 6 and more than that it could be anything. So I am interested in knowing 6, probability of getting 6 heads, plus 7 heads, plus 8 heads, plus 9 heads, plus 10 heads. So I'm interested in probability of getting at least 6 heads, which can be given by 1 minus probability of getting at most 5 heads. I hope you can understand this. So what I'm talking about here is, let me show you through a graph. Let me pick up a shape right here. So think like this. Just pick up one more thing, right? Okay. Let me go to home, insert, one more shape, and I'm picking up, right? This code does a lot. These are the pointers which I create. So this is this particular point. The first one is about probability of 0 heads. The second pointer is, let's say, probability of 5 heads, right? And right after that starts 6 heads, and this is probability of getting 10 heads. I'm interested in at least 6 heads. So this particular triangle, which I'm putting in red, is representing at 6, and this one here is representing 10. So at least 6 heads. So I have in this particular cell probability up from 0 to 5 heads. The total of the probability remains 1. So for out of total 1, I subtract from 0 to 5, and it gives me 6 to 10. So that's how the probability of more than, say at least 6 heads can be calculated. So in this way, any of these particular things can be calculated.